All right. Good morning, everybody. I haven't been introduced yet. So my name is Brian Horsley. I'm a project assistant here at the Test Center. I've been doing a lot of work surrounding urine diversion and planning for a pilot study, which I'll be presenting on a bit later. But right now, I was asked to introduce this upcoming panel, the title being Nutrient Management Options and Costs. I'm not sure why they picked me to introduce this, the moderator of this panel. His name is Scott Horsley. If you didn't make the connection, my name is Brian Horsley. He is my dad. I should also say he's the reason I got into all of this. You know, he's had a long environmental career, and he taught me about urine diversion, taught me about the Rich Earth Institute. You know, I don't even know how old I was, probably 17 years old or something like that. So thanks, Dad, for that. Here's the formal introduction. So Scott has over 30 years of professional experience as an environmental consultant to federal, state, and local government agencies, nonprofit organizations, and private industry throughout the United States, Bulgaria, Nicaragua, the Caribbean, the Pacific Islands, and China. Scott is an innovator in the environmental profession and thrives on bringing innovative and interdisciplinary approaches to challenging projects. Scott has an understanding of the full range of technical, planning, and policy issues associated with water resources and land use management projects. He's served as an expert witness in the field of hydrology in numerous state and federal court cases. He's served as an instructor for a nationwide series of U.S. EPA workshops on water resource management. He's also served on numerous advisory boards and committees to the EPA, the National Academy of Public Administration, Massachusetts Department of Environmental Protection, Massachusetts Executive Office of Energy and Environmental Affairs, National Groundwater Association, and Massachusetts Audubon Society. Scott has received national and local awards for his work in the wetlands and stormwater management fields, and he also serves as adjunct faculty at Tufts University in the Graduate Department of Urban Environmental Policy and Planning and at the Harvard Extension School in the Graduate Department of Sustainability. There we go. Welcome, Dad.
Wow, I never thought that day would come when my son introduced me, but very excited that he's in this field, and it's really gratifying to be part of this. And so thanks for inviting me. Maybe I'll ask the panel to come up and sit while I'm opening some remarks. We're going to continue this discussion, and Abe's going to be on the panel, so we get another shot at him to ask more questions, because clearly there'll be more. And I'll introduce the speakers as they come up here, but why don't we go ahead and grab a seat. While they're, speak up. Thank you. So while they're taking their seats, let me just say that, as Brian mentioned, I teach at both Tufts and Harvard, and about 7 years ago I was asked to teach a class at Harvard, and I had to make a brief presentation, 5 minutes, to pitch my course. And they told me, louder. The mic is not helping you. Yeah. Oh, so the mic's not, okay. Gotcha. You have to use your best scout. All right. So I'll speak up. I'll pretend this is not here. So I was asked to give a presentation on this new course I was teaching to a bunch of people to pitch the course, and I was told I could only use 2 slides. Now I have hundreds of slides, and as Brian said, I've been working in the water field for a long time. But this is one of the slides that I picked. And that was partly, I met Abe, I don't know, close to 10 years ago maybe? He did a presentation at Tufts, and he kind of infected me with this idea. And I always found this to be a great jumping off point to talk about wastewater in general, because it makes you think about, you know, peeing in our drinking water. Does it really make sense? So this is great. I'm excited to be here. And what we're going to do with this panel is we're going to ask for brief presentations, 5 to 7 minutes each, and then we're going to spend most of the time with Q&A. So get ready with a lot of good questions, although I think this panel is going to cover a lot of interesting topics. So I'm not going to read the full introductions, if that's okay, because I know most of these people, but I just met Lynn. So let me, Lynn Broaddus is going to be our first speaker. She's with Broadview Collaborative, and she's been working with the subject matter of distributed water infrastructure, and I love that term because most of us are familiar with collection systems of sewer, and this is another way to look at it, distributed. So I think that's going to be a great perspective. Lynn's also worked with one of my favorite organizations, the Nature Conservancy. We were chatting about that earlier. She started her own organization where she's providing outreach and education and consulting services. And she's currently lives in Minnesota since 2017. And I know that Minneapolis specifically. And I know there's been a lot of great guidance documents that have come out of that area. So we're really pleased to have you here, and I'll let you start, Lynn.
Yeah, there are some seats up front if somebody wants one. Thank you, Scott. I'm really glad to be here. It's great to be at the Rich Earth Institute in person. It's my first in-person gathering, but it's also, for me, especially gratifying to be here on Cape Cod. I've lived in a lot of places, but as a very young woman, I was living in the Boston area, and I visited the New Alchemy Institute in 1981, and it was one of the most formative, I'm going to start crying, it was one of the most formative experiences of my life. And so my career took me in different directions, but eventually started coming back to wastewater and to sanitation and that sort of thing. And even though I have, for the most part, worked with pretty conventional folks, in my mind, my goal has always been to try to bridge that gap as I could, to be a translator between the world that I dreamed of and the world that we live in. And so this concept of the remarks that I wrote, I'm going totally out the window after hearing Abe and hearing Scott's introduction. But this concept of distributed water infrastructure is in sort of contrast to centralized water infrastructure, and it's hard to define because there's a lot of different pieces of it, and it's hard to say this is centralized and this is distributed or decentralized. But we sort of landed on that word distributed because decentralized is really like what it's not. It's negative, right? Whereas distributed just means it's in bits and pieces. We have smaller components to it that may or may not be connected together. And it also allows room for thinking about nature as part of the infrastructure and the role that nature plays in treating our otherwise termed waste products. But what I want you to know is, some of us, I was just talking to Tate, was at WEFTech, which is sort of the opposite of this kind of conference. It's about, I think this year was 22,000 people, and the equipment on display covers 6 football fields equivalent worth of stuff. And it's actually pretty cool, and they have all these operators that are there competing against each other on how to rescue somebody from a manhole and how quickly can they repair a pipe and all kinds of it's pretty crazy. But there's also a lot of science and a lot of policy being discussed. But in that world of people who really think about centralized infrastructure, more and more, it's still just the early leader. You think of the technology adoption curve, it's still just the early folks. But more and more, I've been around them long enough to see that more and more people are interested in I hate to use the word alternative, but we'll use the word alternative solutions, new ways of thinking about on-site treatment, both in urban areas, urban high-rise kind of situations, as well as in rural areas or places like we see on Cape Cod, where it's not, might not call it rural, these are neighborhoods, but they're all on septic and they've got their pond right there, and it's a little shocking when you, like we're staying in a VRBO that is one of these houses, oh, this is what we're talking about. But that world of the mainstream wastewater folks, more and more, they are thinking in terms of resource recovery. Now, they're not necessarily thinking about urine diversion. That would still be pretty out there for them. But resource recovery is very important to them for a number of different reasons, partly permitting reasons, partly because struvite messes up their pipes, partly because more and more they understand and care about the circularity of whether it's water or circular economy in general, but that the world has limited resources and they want to play a part in protecting those. So I guess I don't have anything to say about costs. The title sounds very technical. That's not the role that I play. But I look forward to being able to play a role in how we can continue to bridge that gap between the folks here in this room that are on the bleeding edge of that, very front edge of that technology adoption curve, and seeing how concepts like this and conversations like this can continue to draw in folks from more traditional areas who have their own problems that they need to solve, resource recovery being one, PFAS being a huge one, and whatever the emerging contaminant is going to be 10 years from now. And then also what to do with biosolids. I mean, that's farmers used to want them, and now the public is very afraid of them for sometimes reasonably afraid and sometimes not so reasonably afraid. So how can we work together to solve these problems? I look forward to being able to continue to play a connecting role there.
Thank you. That's great. Okay, so I think we'll go through all presentations and then take questions at the end. So Abe's going to go next. He does not need another introduction.
Thank you.
But I do want to say, Abe, since I met you 10 years ago, I've had 2 students do their master's theses on urine diversion. And one I was interested in your slide about the variability in household, and I think that was a great point. I actually had my students for a week track where they peed every day to illustrate how different the loading is. So I'm still listening to everything you say, Abe, so go ahead.
Yep. Thank you. So you just heard me talk a lot. I will not go on too long. One thing I did want to bring up was a bit of a continuation, a Cape Cod specific or Massachusetts specific aspect of urine diversion that I think is not as obvious because it's regulatory based, but I think it is very important. Is the context of the watershed plans that towns are preparing. This is something. Many of you probably know a lot more about the watershed plans and how they work than I do, but I've learned enough about them to understand that the towns have to come up. They have to either have a watershed plan, or they have to convert all the homes to these advanced, innovative alternative systems over a period of time. So there's a strong pressure to have a watershed plan. If they have one, then they are able to do a number of different interventions in order to bring nitrogen content or nitrogen emissions down, one of which could be urine diversion. The interesting thing about urine diversion, I think, is that the way it contrasts with these enhanced IA systems or with sewers is that it can be done very quickly, and it can be done in some version, like a single toilet in the house, or even one of these portable units for a rather low cost. And what I think is particularly interesting about it is that people can choose to do that. Like some people have already chosen to do it through the Green Center and Mass TC project. They invested a considerable amount of effort into doing that and adaptation to a new fixture. It's an opportunity for people to take into their hands doing some nitrogen removal and nitrogen recovery that is just otherwise something you only do if you have to. Like, I think very few people are going to install a Baumgaertel system at their home because they just wanted to recycle some or remove some nitrogen. They'll do it when they have to, but it's so expensive that it's not something you do like, hey honey, let's do this thing. It'll be good for the pond. Some people probably do, and more power to them, but it won't be common. And I think that it actually plays to the strength, or it mitigates one of the perceived weaknesses of urine diversion, which is people saying, well, what if someone doesn't use the toilet right? They put it in and there's a bunch of guys and they just pee in the back. If people are putting in urine diversion because they want to use it, then they'll be motivated to use it well. And that's what happened with the Green Center Mass DC study. That's what we've seen with the people who haul their urine to our depot, or the folks who put it in their homes. So from a municipal perspective, it seems to me like if there are people who want to do urine diversion, whether it's permanent retrofits, or whether there can be figured out a way to do more portable versions, either of those things. If someone's motivated to do that, And the town is in a position to facilitate that, whether it's by dedicating resources to it or just making the process easy, or offering some sort of reward for the urine that's collected. It could be any manner of things. But if the town is able to encourage that, it's probably a highly effective way, because the people who choose to do it are going to be the people who will do it well. And that is maybe not obvious when you're thinking about comparing the different systems. If you're just looking at the numbers for what a house makes and what you could get out with the different approaches, you might not take that into account. But I think it's a really important factor, and it's an empowering factor too, because it's something that people can get excited about and feel good about, and people even compete about it in Brattleboro. We have a very serious competition every year. It's called the piss-off competition, and people work hard to win this. There is a trophy. It is the Judy Zemmel Cup. It's gold. It's got all sorts of decorations. It goes from house to house. You only have it for a year. Then you have to pass the honor on. And there are lifetime achievement certificates. There's the 100-gallon club. All these things. It's published in the newspaper. People, we have a press release, and people are very proud of that. They hang the certificates in their bathrooms. So people do get into this in a way I've never seen anyone that excited about a septic system in their home. So I would just, I guess, put in the idea to not overlook that, and not overlook the power that motivation actually helps people to do the things that you might doubt they would do, like use the toilet properly, or take the process seriously. And I think the same goes for the Blackwater diversion, whether that's with the composting toilet or one of the other systems. It's not for everybody. It would not end well if any town were to mandate that everyone in the town must use a certain kind of toilet. People don't want to be told how to do their business. But if it's an option for people who want to choose that route and are motivated to, then I think that's where that tool in the toolbox fits in. Some people want to pick up that tool and use it. Some people don't. If it's in the hands of the right people, it's a powerful tool.
Thanks, Abe. So I'm just thinking maybe in the future we could have a competition, Cape Cod versus Vermont.
Ooh, you're on.
We can beat him, right?
I hope you do.
So our next speaker is Brian Baumgaertel, who you've already heard from, and he doesn't need an introduction either, but I will just add that in addition to what he mentioned earlier, he did serve on the Mashpee Board of Health as chair. So he has not only the perspective of running this place, but on the front lines of regulating wastewater in Cape Cod, which is no easy task. And so Brian, take it away.
Thank you. So in the beginning, if we think way back, in the beginning, there was distributed wastewater treatment, right? That's where we all started, holes in the ground. And we decided that wasn't good enough, so we started centralized treatment. And now we're kind of deciding, well, that's not good enough either. We're going to go back a little bit and try to figure out more ecologically friendly ways of dealing with our waste. I've always advocated for what I've called a blended approach, which is not, pick one or the other. It's look at the landscape that you're dealing with, the layout of where your buildings are and where the central parts of your towns are, and figure out what works the best. And don't just assume that the technologies can't complement one another, right? We can sewer and we can do urine diversion and save our plants from having to treat a little bit more nitrogen. We can sewer and we can do IA systems. We can do IA systems and urine diversion. And we can have houses that combine those things so they're not mutually exclusive. And I think that's an important thing to remember. So to go back in time for me personally a little bit, I grew up in upstate New York. And I didn't realize it until I started working here that we had essentially what was a straight pipe that went out into the side of our house. We had a septic tank that I think hasn't been pumped in probably 50 years. So basically, not non-functional. And I think it still hasn't been pumped to this day. So that was my first exposure to it. And when I started coming to Mass TC about 10 or so years ago, I realized the power of this place to inspire people to do better and do something a little bit different, which has always been the very interesting part about this place to me. You know, it's not, as I mentioned before, it's not just about certifying technologies so people can sell them. It's not just about research and development. It's about bringing folks like you together to think about doing things differently and doing things in a different way with hopefully a better outcome than the direction that we're headed now. So most of my time here has really been focused on how do we get rid of nitrogen? And I think most people think about it in terms of like, how do we get rid of this stuff? And as we all probably know in this room, and I won't preach to the choir, that's a ridiculous concept, getting rid of nitrogen, right? We spend about 3% of global power use taking nitrogen out of wastewater to put it in the atmosphere, and take another 3% of global power use to suck it back out of the atmosphere and put it in the food we eat, and then we take another 3%. So we've created this ridiculous cycle of like, let's get rid of nitrogen, let's get rid of phosphorus. And as human species, we tend to do that, right? We tend to speed up the natural processes a little too much, and we break them. So, as I said, most of my time here has been spent around, let's figure out how to get rid of nitrogen, let's figure out how to get rid of phosphorus. And then Brian Horsley came along, and he said, hey, how about this other stuff here? How about, why don't we focus a little bit more on composting toilets? How about urine diversion? And he's really been the driving force behind this here. I get to be the director, and I'm the one who gets to sit up here today. But I want to make sure that as far as our facility goes, Brian really gets the credit for the work that the test center is doing on this stuff. So as we look forward, I think urine diversion for Cape Cod, composting toilets for Cape Cod, IA systems for Cape Cod, sewers for Cape Cod, I think they all have a place. And it's up to folks like you all and folks like us here at MassTC to advocate that we don't just focus on one particular technology over another, or that we we merely use one technology in one place and one technology in another. We really have to figure out how we can blend all those things together to get the best outcomes that we can. So as I said earlier, I'm happy to have you all here, and I'm happy to listen to your questions in a little bit, which is the best part about a panel. So I'm going to end my remarks there and turn it back over to Scott.
Thanks, Brian. I didn't know they said you all in upstate New York. So our fourth speaker is Bruce Walton, who I've gotten to know pretty well over the last 5 or 6 years. He heads up a panel for the New England Water Environment Federation, specifically on developing wastewater on-site or distributed technologies. And it's been really effective at promoting this, which we really need. He comes from a business background. He worked for IBM and Hood Sales, too, I believe.
A long time ago.
So it's really nice to have that business perspective, which we need. As Abe said, we need to commercialize this. We all know it's a great idea, but the next step of getting into the economy is tricky, and I think Bruce's background is really helpful. So, Bruce?
Thank you. I got into this through personal connections. A former salesperson from IBM ended up going to the Kennedy School and joining EPA, and we ended up, she remarried and moved to Needham, where I live, and we ended up commuting together. And she was talking about putting together a water technology innovation cluster concept, and they said, go fix the water problems on Cape Cod, Buzzards Bay, and Narragansett Bay. And we commuted for a while together, and finally I realized this is something that could be useful in my business, which was executive recruiting. Gives me something to talk about with people who, instead of asking them, do you have a search right now, which they never do, we could talk about something that's important to people who live along those coastlines. That's how I got involved in it. I wrote an article that caught EPA's attention, and without going into all the details, I was on the board of an organization that she had created called New England Water Innovation Network. We were trying to get new, innovative, smaller companies into the water world on the basic assumption that more cement was not going to fix the problem. We merged into NUWEA, which is the Wastewater Professional Association, about 3 or 4 years ago. and helped create an innovation council within their management structure. That's a big organization. They have 55 different committees, and we became one of them to get the nurturing that the president of Noe-Hays felt we deserved. I felt I was going into the lion's den, but to their great credit, they've never said no to anything we wanted to do. We created a website. I've got business cards, which I'll keep up here. If anybody wants to look at the background or what we have produced in support of this arena, happy to have you do that. And everything we've produced or found that other people produced that could be useful for self-education in this area has been posted. We've got about 80 links on our website at this point. The task force has evolved. It was about 40 of us, maybe a dozen really active folks, as task forces tend to be. And it's broadly based. We've got a half a dozen vendors. We've got academics and engineering consultants and whatnot. And the first 3 years of our existence was what works and how do we manage it. And that provided a lot of input to the concept of the responsible management entity, which is now being developed by Mass TC. So we're happy that was helpful. The key thing that came out a couple of years ago from the vendor community in large measure was they couldn't get good cost data. And there was a lot of potential mis or disinformation out there. Vested interests would, muddy the waters. So I spent about 7 or 8 months trying to figure out what are good comparable cost comparisons between EIAs. Now we're moving towards nitrogen removing septic systems as the moniker, and centralized sewering. The key, we wanted to reduce it to a per home cost, and that involves an awful lot of assumptions. When you think about allocating things, we gathered anecdotal data. I have a home in Barnstable town, which has 7 villages in it, which confuses a lot of people. But they had a wonderful website where a lot of information, including their comprehensive wastewater management plan, was posted. So there was a lot of data that we could get at. And I looked at that, put this together, reviewed it with the town CFO. Basically, he had some good constructive suggestions. And that's the basis of sort of what I'm here to talk about. The focus here was total cost. Who pays for what is a political discussion. And when you talk to DPWs or health departments, they tend to want to look at their budget and their view of the world. And that may skew the analysis in a way that isn't constructive overall. So I looked at total cost, and I'm not going to go through a lot of the numbers, but the buckets we sort of identified in studying Barnstable. Collection system, which is a very big piece of the puzzle. The connection of the home to the collection system. The treatment plant, and there are big assumptions when you think how do we assess or assign a per home cost to a treatment plant upgrade, and understanding that Barnstable is now in the middle of a $110 million plant upgrade. Some of that's for PFAS, some of that's for other reasons, and so how much of that do you apply to the analysis we were doing? And interestingly, soft costs are 30 to 35, 40% of construction costs, and they tend to get ignored along the way. And then there's the ongoing operations and maintenance, O&M. When you look at EIAs, there's a lot less data yes, there's a lot less data in the atmosphere to look at. So we talked to vendors who were in the middle of it and had SRF applications, the state revolving funds. We figure those numbers are going to, somebody has to stand up and defend those numbers. We interviewed the folks like Brian at Mass TC, talked to vendors who were in provisional permit level. Our mission as a task force, I should have noted, was to help accelerate through the permitting process and into the market successfully the new generation of nitrogen removing septic systems. So we talked with provisional permit holders who had actually stuff in the marketplace. We talked to consultants, and we talked to the folks down on Long Island, which has the same problem that Cape Cod does. It's a sole source aquifer on a big sandbar, and they have 350, at the start of 8 or 10 years ago, they had 350,000 cesspools and huge water quality problems. And so they had a perspective that we wanted to include. The first step in this was to figure out on a per home cost and then translate that to the extent we could to a cost per kilogram removed. The simple numbers, the sewering was costing about $100,000 a home, all in. Now, interestingly, and this comes back later, the town was limiting the cost to the homeowner of about $20,000. So that means that somewhere around $80,000 was being subsidized by taxes and other funding sources, which is okay because it's a town benefit, not a homeowner benefit, by getting rid of nitrogen. So there's a lot of political discussion about what can be afforded, but it's a reasonable discussion. EIAs came out about $50,000, so about half the cost on a per home basis for sewering. Now, I would tell you that the DPW at Barnstable, in their good faith, didn't agree with my numbers or the way I calculated them. But 6 months later, I was in a meeting and they're using those numbers. So they may have gotten to them in a very different way. Scott's been through that with Wellfleet, where one way of calculating things was perhaps challenged. They went to another consultant. I talked to that consultant. He said, I used a different approach. I got to the same numbers. So there's some hope that these are at least directional and reasonable, if not perfect. Interestingly, OM operations, I didn't talk about the buckets. For EIAs, design, permitting, equipment, installation, and O&M, but there's another M to attach to that. It's called monitoring. In order, to the points you were talking about, for the state to be comfortable, they have to measure what's happening over a longer period, over the lifetime of the installation, to make sure that the systems are performing. And one of the key attributes of the new technologies is they do take a little electricity. They're not going to manage themselves. And the experience in other places like Chesapeake Bay, you put in a system and the house gets sold, the new owner looks at a switch and says, I don't hear anything, I don't see anything, I just this click, and then you've just lost the extra performance of the IA system. So there is a need for some kind of oversight and management. Again, that goes back to the responsible management entity concept. And one of the things that's important in that OM and M, operations, maintenance, and monitoring, is replacement cost calculation. So what we learned in OM and M, when you talk about the total cost, is that it's almost a wash between sewering and nitrogen removing septic systems. It's about $1,100 or $1,200 a year per home. Now, interestingly, the databases that support the industry talk about average charges in the $400 to $500 range. There's another opportunity or conclusion that there is a subsidy going on to the homeowner by the town. But when I looked at $1,100 or $1,200 a year, it was basically a wash. So the real big issue is what are the capital costs of installation, is guiding any analysis of cost. Translating that into cost per kilogram removed, and I'm sorry I didn't get a slide to put it up, but we did the calculations, and thank you, Scott, for giving me the guidance on how to do that. In general, the 50%, maybe it's 60% number cost reduction comes through on the cost per kilogram removed. The general numbers, and these are very gross and not based on a lot of data, but they look to be maybe $200 to $450 per kilogram removed, and that's an annual number based on an average, of 20 years of calculation, but an average annual number. The EIAs, EIAs generally look about $200 to $450 per year in cost per kilogram removed. The sewering, based on these numbers, comes out around 600 plus dollars cost per kilogram removed. So whether it's a third or a half, then it's certainly a significant number. The Nature Conservancy has been supporting us in a big way. We're working as we speak on a model that gets into a much more in-depth look at it, including inflation and financing costs, and the numbers basically cross-foot with that analysis on an initial look. I think one of the key points that we have to think about is what I'm calling equitable treatment. We came up with a concept called subsidize to equalize. If sewering's getting subsidized in a big way and we got to do stuff, why should you penalize someone for an EIA installation that costs $50,000 instead of $20,000, which was the allocation for connecting to a sewer? Those are issues that the towns are in the process of wrestling with right now. And I think Scott's in the middle of a little of that, so he can comment there. My final point, I think there are 4 drivers that I try and keep in mind when we talk about this, and I think it's important for any of these options. There's performance. Does it do the job? The cost. At some point, if we entirely did this sewering, somebody's going to have to stand up in front of the electric and say, we spent a couple or $300 million that we might have saved if we had done a better mix of technologies. And the electric's going to the electorate, thank you, is going to end up paying for that. There's time value, and then there's location value. Can you put the resource where it's going to be most effective in the most time-sensitive way? Sewering, where there's density, is the best option in my view, but I've got a situation within Barnstable where a saltwater bay was projected to go dead in probably 5 or 6 years from now. The sewer isn't going to get there for 20 to 30 years. So what do? We're looking at temporary, collection cluster systems, and I didn't really distinguish between individual and cluster. EIAs encompass the concept of an individual system in an individual house, but also a small group, or we call them clusters, where the septic is collected and treated locally in a distributed way. One idea, collect, process for 20 years on a leased basis, or 15 years, and then when the sewer gets there, take out the processing, connect to the sewer, and you've started to impact the problem, but have the ultimate solution downstream. So that's where time and location values come in, and I think they're just part of the solution. That's my pitch.
All right, Bruce, thank you. Good news is we got 15 or 20 minutes for questions. I do want to just tie together Bruce's comments on cost to what Abe talked about earlier. So just to generalize, sewer costs on the Cape, we're calculating between $500 and $1,000 per kilogram to remove. A kilogram is 2.2 pounds. I mean, think about those numbers. Spending a lot of money. The EIA systems, or the NRs, we're calling them, nitrogen reducing, as Bruce said, maybe $300, $400, $500, $600 per kilogram. So they look pretty cost. But I think I saw on your slide, Abe, about $40 or $50 a kilogram.
It was I can't remember the slide now. I think it was 70 something to 200 something.
You're right, 70.
Or
So,
I can't remember.
It was 70 to 300.
Arthur's good with
thank you, thank you. So I just wanted to connect these numbers. So today's discussion, we're clearly focusing on the right thing here, because most of us want the low-cost solution. As Abe said, it doesn't fit everywhere, but certainly it should be part of the program. So I just want to tie those comments together. So let's get back to those hands we had up earlier. We'll start with you, sir. And we do want to speak into the microphone.
Yeah, my name's Scott Norum. I'm from Harwich, part of a Harwich Ponds Coalition that was formed 1 year ago. And it seems to me, I did a lot of the numbers that you just talked about, Bruce, and I did like a 50-year present value of urine diversion and collection and processing versus sewer. And we have data for the sewer costs because we have a 25-year, 8-phase plan in our town. And it seems to me the challenge is to use those numbers to make the point that you could remove the nitrogen that the state requires us to, or our plan requires us to, with this other tool, and maybe knock a phase off of this $300 million 8-phase project. And I think the problem is that the taxpayers have not been sufficiently informed about exactly how much this is going to cost eventually. So if they don't know how much they could be saving with a different approach, and neither do the town officials. So we really need to somehow band together to come up with a methodology that makes that point as powerfully and as accurately as possible. And I think you're trading higher operating costs for the urine diversion and all of the sort of collection and processing required in exchange for lower capital costs, which the sewering systems require. Plus all the advantages of being able to jump right in with nitrogen and phosphorus removal with the urine diversion in a year instead of in phase 6 or 7 down the road. And combining, the density considerations, the proximity to ponds. Often in our town, the proximity to ponds are the least dense areas, and they're not even touched in 25 years. So it seems a no-brainer if you can tackle those very sensitive areas and get some credits, and I don't know how that works with the state, how you actually capture those credits and use them to knock a phase off of your sewering project. That would be the formula for taking advantage of this and saving money at the same time.
Well, I'm just going to quickly mention, yesterday we had a meeting, we're involved in the town of Barnstable, the Comprehensive Wastewater Management Program ad hoc committee. Butch and I and others are on that committee. So we're looking at the first 5 years, and that's exactly what we were talking about yesterday. Barnstable has a 3-phase sewering program, $1.5 billion. We're now looking at phase 3 saying, I'm not sure we need it or can afford it, and we're doing exactly what you suggested, looking at all these technologies as a way to maybe mitigate or as an alternative to phase 3. But is anybody else on the, yeah, Kate, go ahead.
Yeah, regarding the question of how do you take credit for that, for those nitrogen removal kilograms, or pounds, pounds or kilograms? How's it usually discussed? I keep hearing different things, and okay, I like kilograms. So the question of how that's done, my understanding from our work on the pilot study planning group is that that the state is welcoming a management plan, a watershed plan that includes urine diversion. Until a plan is submitted and accepted, there's no official statement on how you can or can't do it. The towns propose things and the state says yes, you can or can't. But they've been very encouraging with the concept that that over the first 5 years, because the plan is renewed every 5 years, I believe, over the first 5 years, any urine that's collected can be totaled and entered into the tally, and then that's what establishes that the town is able to deliver those pounds or kilograms of nitrogen. So so they're not really encouraging that that a town does math and say, we'll do this much over the first 5 years, therefore count this as our first 5 years. It's more that it's in the town's interest to build out what it can in the 5 years, and then it can take credit for what it's actually measured, because what gets measured in those tanks has actually happened. It's kind of more real than most of the other metrics for nitrogen removal. And so since the thing happens every 5 years, even though it's not clear what's going to be achieved now, it doesn't really matter, because it gets established on an ongoing basis. And then when you get to that point where you're on phase whatever of the plan, then it's clearly established that the town is removing so many thousand pounds for urine diversion, and that's as strong a figure as anything else in the plan. So it's pretty conducive to fitting their rolling 5-year plan. It's come together kind of nicely in that way.
Thanks, Abe. Bruce, do you want to add something?
Yeah, I think it's worth noting that the nitrogen-removing septic systems aren't generally permitted yet at the rates that we need them to be to fix the problem. And so we're anticipating that within 5 years, there are going to be a few options available to us. But the state, in its wisdom, developed the concept of adaptive management, which says every 5 years, every town which reports its approach has to poke its head up, look around and say, are there new technologies that would change the way we go forward in a better way? And so with Scott's leading the first adaptive management review committee for the town of Barnstable, what we're really projecting is, what are we going to learn about these technologies as they get permitted over the next 5 years, so that we're prepared to make more aggressive use of them at the next adaptive management review. So there's still a lot of modeling.
Lynn, go ahead.
Yeah, I just want to add, in addition to needing to have those hard numbers, looking to the experiences that other communities have had, and all the kind of logical stuff that makes sense in a room like this, and maybe makes sense to an elected person who's in a position to make a decision. But for the rank and file person, they don't have time in their life to think about this. The numbers glaze over. They don't know what nitrogen is, and they don't know why they should care. And so make sure there's a place for being able to tell the story and draw people in. And I use I've been a little shocked myself. I've been trying to reinvent myself as a writer, figure out how to write. And I've written a few pieces on the impact of nitrates and nutrient pollution, and focusing in on the impact on human health. I haven't heard in this discussion, other than sole source aquifer, the role that this plays in drinking water, and the impact on human health at numbers way lower than what the permit, the regulatory line is. And when you tell those stories, people they don't just start to care. What I have learned, and I've got to balance this out, they start to get really anxious, and they want to do something. They want to know, what can I do? So be sure that is part of your work as well. It's on top of the numbers.
Okay, another question. Right here? Yep, you. Microphone's coming.
Hi, this is a really great panel. I have a lot of questions, but I'm going to focus on one thing. Sorry, I'll get louder. So, to Lynn's point, one of the piece of information, I do a lot of talking to centralized water people, because that's the world I come out of, and trying to make this story. And one of the really helpful statistics is, if you look at our industry over decades of putting effort into nutrient management, we've made about 11% nitrogen and 20% phosphorus recovery progress. That's the embedded infrastructure of the centralized systems. And tinkering with it some more is not going to move that number any further really much at all. Maybe on phosphorus if you get more plants doing struvite, but not on nitrogen. And so the only solution there is what you were discussing at the panel, which is you need all the solutions, right? There's different places for the different solutions. And one of the things happening in the water industry right now, which I'd love to see in the estimates that are being done by Bruce and others, is carbon intensification is a very big emphasis of the water industry right now. And urine recycling allows carbon intensification to happen. What that means is your centralized plant only focuses on carbon. It goes back to the very beginning of what treatment plants focused on was pathogens and carbon. If you remove the nitrogen and phosphorus, then they can turn that carbon into a commodity product. But if you have the nitrogen and phosphorus there, it overwhelms the cost of the centralized treatment. And so I'm wondering if in the analyses you all are doing, we also think about, because if we're going to talk to the people at the centralized systems, we have to be able to speak to their language, and they have to understand how this helps them achieve carbon intensification. So I wanted to just put that out there as like the next step on the estimation process of dollars per pound of nitrogen or dollars per gallon to help with that story.
Thank you. Who would like to respond to that?
I take that as advice. I think that's good advice.
Well said. Okay, thank you for that comment. In the back, right there.
I just wanted to say, I feel like the biggest elephant in the room is that people don't know what they themselves are doing. There are no regulations about whether you have your septic tank pumped. If you sell a house, it has to be upgraded, but in my case, I inherited a cesspool, just like Brian, and I try to pump it all the time, but I know what I'm doing, but most people don't. And most people, and I can't understand why, you know, everything else we have is regulated and we know what we do. We know how much electricity we use, we know how much water we use. Well, actually, we don't really in Falmouth, but, and this is something that you don't have to do, and it's affecting the whole public health. So why can't we start by having everybody basically get a, you know, failing grade on their system and know that they have 20 years to have to do something about it, and then they'll want to embrace these technologies.
Well, humans don't like punishments, right? No, I mean, I think part of that is like you talked about electricity use. We want to monitor our electricity use because we get to do fun things with electricity, right? And we get to do fun things with water. We get to stay alive drinking water. When it comes to our waste, most people just want it to go away. And that's really true whether we're talking about our wastewater or our solid waste. Solid waste is another major problem. We look at the amount of plastics we produce and people think that it's being recycled, and it's probably not. But I think that is a valuable way of looking at it. We need to figure out as a group, how do we change the perception of our wastewater? How do you make it so that somebody is interested in where it's going and what's happening with it? And I think urine diversion in some ways can help with that because it helps to, and I hate to say it, it provides the incentive of monetizing a little bit, right? Like if you could get your urine tank pumped and you get a little check because you now sold that phosphorus and nitrogen, there's a great incentive, right? Oh yeah, I want to use this. Why wouldn't I use this? I think those are some of the ways, but it needs to be part of a broader discussion. Like how do we get people really engaged in this stuff? Because it's very difficult for sure.
I just remember the first book that I read on urine diversion was called Liquid Gold. It's a good book. Right, go ahead.
Hi, yes. My question is, I'm just curious where the pilot, that the urine diversion pilot is, the objective of the pilot and the regulatory hurdles that it faces, and what hopefully the outcome is. If someone could talk about the pilot that's going on, that'd be great. Thank you.
Can I put my son on this one?
Sure. We have actually two presentations coming up on both of those topics. So maybe let's save that for those
So you want to
presentations.
hold on that
Yeah.
question? Hold on that question?
Yeah, I think so.
Okay, we'll get to it. Yes.
So I live in Wareham, and we are also facing huge sewering costs that won't be completed before I leave the planet. I live on a pond. It was closed this summer for a while, so I'm very concerned about the nitrogen. And we've been trying to educate people in town, including the town leaders on various boards. Lynn, you mentioned something about the struvite messing up the wastewater pipes. Our pipes are dangerously old and decrepit. Is that a point that could be helpful in promoting this idea as an option? There are many things, pluses to talk about, but is that one that might be key?
Without knowing the specifics of your town, like how long those pipes are and what they're going between and all that kind of stuff, probably. Now the struvite, so struvite is, it's like hardening of the arteries for a pipe, and it naturally, like if you don't flush your toilet I can say this in this group, if you don't flush your toilet for a while, you get that that phosphorus buildup in your toilet, and you can get rid of it by lowering the pH in the water, and it dissolves out. And that's basically what happens at a wastewater treatment plant. They manipulate that pH to try to get the phosphorus struvite to precipitate out in the right place rather than in the wrong place, their pipes. So whether the pipes are too far gone to get that stuff to precipitate out, maybe they have to replace it. Maybe they can flush it out with, I don't know, somebody here who has operated a collection system would be able to speak better. Although my understanding is it's more of a problem at the treatment plant itself.
More of going
going
forward and the maintenance required.
I think that, and Bruce or somebody who's done the calculations can speak more, but one of the things we don't talk about is one of the other stressors. When you look at the American Society of Civil Engineers, they give the grades to our infrastructure every couple of years, and they give the grade to wastewater, and it's usually like a D something or other. And that D something or other is not because the treatment plant doesn't work, it's primarily because of the collection system. And the collection system is the weak point in our centralized, it's expensive, it's what's subject to failure. You think subsidence, that pipes don't like subsidence too much, and that's the kind of thing that coastal areas have to deal with. You think of resilience to major storms, connections through pipes are what make that very difficult. So I think if resilience and if cost of maintaining those pipes is part of the equation for your community, then yes, that is definitely an argument for doing decentralized or distributed.
Let me get a question from this side of the room. I've been ignoring you guys. Yeah, go ahead.
Sorry.
Hi, everyone. I'm just curious if when we're thinking about cost, a lot of times we think about with more on-site systems that are more innovative, we're thinking about the increase in operation and maintenance costs. But do you think about, do cities think about the cost, the lost GDP from nitrogen going into the bay in terms of their calculations and thinking about by not fixing this system, it's actually more of a loss? And does that ever go into the calculations in terms of thinking about how a city or a state provides sanitation solutions? That makes sense.
I think that's been that concept has been one of the major drivers in getting the ball rolling forward on a lot of this, is because unfortunately it seems like it wasn't enough just to say, well, the quality of our bays and estuaries is not great and it's getting worse, right? I would say probably 10, 15 years ago, it seems like the focus really shifted away from, well, we have an ecological problem, to you're going to lose value on your home, right? It's the truth. It's a tangible thing for a homeowner that says, whoa, I don't want to lose my property value, right? So that has been a big piece of the discussion in the towns, which is the cost of doing nothing is higher than the cost of doing something.
The only thing I'd add to that is, we might remember there is a lawsuit that was quite successful pending with the Clean Water Act that has a daily fine, which I don't think EPA wants to collect, but the doing nothing alternative doesn't cost nothing anymore as well. Yes.
Yeah, I wanted to hear more about the cost for permitting haulers or for site permits. How complex are those things? How much challenge do they present in terms of urine diversion, if you were to try to implement a rich earth type of solution?
Yeah, I guess what I can share about that is in Vermont what we know, because in Massachusetts, I'm a part of this team that's looking into that and has some estimates, but I'm not even the authority on those estimates within that team. In Vermont, the hauling is very inexpensive to be a hauler. I think we pay, a question for Arthur, is it $50 a year?
Yeah, I can
It's not much. No, I didn't need to get into that much. I just want to check the number with you. It's about $50 a year, right, for that?
Yeah.
Yeah.
And I have more information if you.
And you'll be doing a presentation, right, on the operations?
Yeah, I'm not going to talk as much
Okay.
about that. But.
Okay. But the hauling cost in Vermont, the license to be a hauler is small. We operate a hauling operation. We're a nonprofit, so we do that. We do that not to to earn a profit. Do you have a number you want to share on what it costs per stop or something like that?
No, I was going to just talk. It seemed like your question was a lot about like permitting for site for on-site systems. Yeah. So, right, we pay there's a state fee of like $270, plus we have to have someone who's a licensed designer submit the application. I would say that costs anywhere from $300 to $800. So the permitting for getting the permit to build the system is probably somewhere between $500 or $600 to $1,000.
And I do know that in the pilot study planning team, we used higher numbers because in Massachusetts apparently those costs are higher than in Vermont for whatever reasons. For the hauling itself, I know that that when we were working with a septage hauler, the cost of hauling septage was around 30-something cents per gallon, and part of that was the cost of dumping at the wastewater plant, around 10 cents. So about 20-something cents per gallon was their fee for actually transporting it. For urine hauling, I think that the fee will be higher because it has to be a different tank. It can't just be the same hauling tank mixing everything together, so that cost will be higher. I would imagine that 20-something cents per gallon transported would maybe be ultimately some kind of a floor. I wouldn't expect it to ever be cheaper than that because I wouldn't think that hauling urine would ever be cheaper than hauling septage. If anything, it would be more expensive for the care you have to take with the urine beyond the septage. And I think that the current estimates that were given by a couple of organizations were from $1 to $1.80 something per gallon for urine transport. I assume largely because there's an investment in equipment for urine transport that a hauler would have to make. So, yeah.
We operate in Massachusetts currently as haulers and are available to do this kind of distributed collections. We operate as haulers, and there's actually a fee we pay town by town to haul. In Massachusetts, in Vermont, it's a statewide hauling fee. Massachusetts, you pay town by town.
Do you want to say anything about what the hauling cost for urine?
I can't speak to that off the top of my head, but happy to chat offline with folks who are interested.
Okay. I'm being told that we need to move on.
Minimum fee of
$100, okay.
For 155 gallon container.
Okay.
All right,
I imagine those numbers. That was an early project, and I wouldn't assume that any of those numbers are set in stone. But Rachel, do you want to share your?
Yeah. So some of that, I imagine if we were to set up clusters, that fee would change.
This is a single.
Yeah, it's about sort of whether you're in our service area or not.
Mm-hmm. Right. Okay. And that's. Well, if someone wanted to follow up with you, would they just email info at wasted?
Yeah, that would be great.
What wasted dot?
Earth.
Info at wasted.earth if you want to talk further about hauling costs for urine with wasted. Thank you very much. That's great.
I'm told we got to move on here. We're a little behind schedule. Great questions. I'm sure everybody's going to be around so we can follow up on this, but I want to thank the panelists.